Today's lesson is on inverse variation. Recall that back in Chapter 4, we talked about something called direct variation. We did this when we started talking about slope and started graphing lines. Direct variation means that y varies directly as x. And if you recall, we had the equation y equals kx, where k was the constant of variation, and as we later came to find out, k was also the slope of that line. Well, today we're going to talk about something a little bit different, and it's called inverse variation. And what that means is y varies inversely as x, y varies inversely as x if x times y equals k. So that's our equation for inverse variation. Notice how it's different from y equals kx. This one is xy equals k, and as we'll see when we go to graph it, if I divide both sides by x, I can write it as y equals k over x. So instead of k times x, it's k divided by x. Let's take a look at an example of a problem that you'll see in the homework. Write an inverse variation equation that relates x and y, and then solve it. So notice they're asking for two things. You need to write the inverse variation equation, so that will be in the form xy equals k, and then we need to solve. The problem says, if y varies inversely as x, and y equals 5 when x equals 12, then you need to find x when y equals 15. So let's start with our basic inverse variation equation, xy equals k, and let's plug in 5 for y and 12 for x. So 12 times 5 equals k, or k is equal to 60. So my inverse variation equation is xy equals 60, which I discovered to be k. So that's the first part of your answer. That is the inverse variation equation. Now the second part of the problem asks me to find x when y is 15. So I'm going to use that equation, xy equals 60, and I don't know what x is, but I do know that y is 15, and those two multiplied equal 60. So dividing both sides by 15, solving for x is equal to 4. And that's the second part of my answer. Another thing you can do with an inverse variation equation is graph it. And here's an example of a graph that you'll see in the homework. It says graph an inverse variation equation in which y varies inversely as x when y equals 2 and x equals 4. First thing I would like to do is to write the equation so that I can make a table and plug some values in. So xy equals k, x is 4, y is 2, so k is equal to 8. So that gives me the equation xy equals 8, or in order to make a table, I would like for that to be solved for y, so y equals 8 over x. Now when I make my table of values, recall that what I do is I pick values of x, plug them into this equation, and then figure out what y is. Now notice that x is in the denominator. It's underneath 8. So whatever x is, I'm going to take 8 and divide it by that number. So for my values of x, I would really like to choose numbers that will go into 8 evenly. So for example, I don't want to pick 3, because then y would be 8 over 3, and I don't want to have to graph fractions. So let's pick some numbers like -8, -4, -2, -1. Notice I can't choose 0. X cannot be 0 because that would make my denominator 0, and that's undefined. So let's pick some positive numbers. How about 1, 2, 4, and 8? And plug each one of those x's in. So 8 divided by negative 8 gives me a negative 1. 8 divided by negative 4 is negative 2. 8 divided by negative 2 is negative 4, and so on. Now let's graph those points and see what it looks like. Negative 8, 8, and negative 1 is that point there. Negative 4, negative 2, negative 2, negative 4, and negative 1, negative 8. And 1, 8, 2, 4, 4, 2, and 8, 1. So your graph looks like this. Notice that this part of the graph, as it's heading towards the x-axis, it never will touch the x-axis. The same thing with the graph as it goes down this way on the y-axis. It approaches the y-axis but never touches it. The same thing is going on up here in the first quadrant. It's approaching the y-axis and it's approaching the x-axis. We say that the axes are asymptotes. The curve of the graph approaches that line, but it will never touch it. All of your inverse variation graphs will look like this, with a curve in the first quadrant, a curve in the third quadrant, or if k is a negative number, you'll have a curve in the second quadrant and a curve in the fourth quadrant. So those are the two types of problems you'll see in the homework, and I'd like you to practice those by doing numbers 2 and 6 on page 850. Do those in your composition notebook, and I will check them in class tomorrow.